Hey there. In this video, I'm going to try to summarize a lesson that was conducted in class. And the way that I share it is going to be a little bit different than what students did in class, but I would like you to at least get the essence of what was discussed in class in case you had to miss it for any reason. So this activity was done in preparation for a test that ask questions about variables in experimental designs, what a research question is, what a hypothesis is, and how to identify and write all of those things: independent variables, control variables, dependent variables, research questions, and hypotheses. So there are a lot of ways that data can be represented, or experimental information can be represented. And it includes data and charts. It includes an experimental summary where you're just looking at words, and we're just going to navigate strategies that you can use to be able to dissect, not like biology dissecting, but because that's kind of gross, but you can really dissect information and get to some fundamental information, like what is the experiment about, what was the researcher controlling, and what was he or she ultimately trying to figure out. So in an experimental design, in experiments, we have variables. Now, the independent variable is the variable that is controlled by me, as I'm a researcher. Or if you design the experiment, then you're the one that's controlling this. This is what you're making a decision about. You're manipulating and you're deciding to change. It can be thought of as the cause. Will changing cause something to happen? And on a graph of experimental results, it's always going to be on the x-axis. And a way in class that I tried to have you remember that the independent variable is all about the thing that the researcher is controlling, is to just give an example of me. I'm an independent researcher. I'm strong, I'm confident, I'm in charge of this experiment, and these are the choices that I'm making because I want to see if I change something, which would be an independent variable, if it will have an effect, or if it will cause an effect on something else. And that something else ends up being the dependent variable. So the dependent variable is the results of the experiment, and it can be thought of as the effect. So the independent variable causes, and what it causes is the effect, the results. And on a graph of experimental results, it will be on the y-axis. Now, controlled variables are all variables of an experiment that remain the same for all trials. It looks like my picture here is covering that up a little bit. Boop, there you can see it, and I'm going to put that back. I hope you like my sound effects. Okay, so this was an activity that students looked at in class previously, of an experiment in which the researcher was looking to see if the number of Alka-Seltzer tablets had any effect on how much temperature changes in a reaction. So in this case, the researcher was controlling the number of Alka-Seltzer tablets. So this is what I'm controlling, which makes the number of Alka-Seltzer tablets the independent variable. All right. Now what you'll notice here is that the volume of vinegar is the same. The room pressure happens to be the same. The initial temperature of the solution has to be the same. So these are all not balloons, but controlled variables. But they do kind of look like balloons. All right, now what we're measuring, the results, is the final temperature. And that makes this the dependent variable. Okay, so in this we're going to talk about a research question here shortly. The research question could be, will the number of Alka-Seltzer tablets affect the final temperature of a solution when the Alka-Seltzer is added to vinegar? So with variables and graphical analyses, something really kind of crazy that I did with kids is in class I kind of went on and on about how I am an independent researcher. I make the choices, and really elaborated on that. And after that, I did something really kind of crazy, and I'll draw a picture of what I did. This is me, and I just laid right on the floor. And I asked students, it's like, okay, I want to remind you, I am an independent researcher. I'm making choices. I'm deciding what I'm going to control or manipulate in this experiment. Excuse me. Why am I laying on the floor? And there were lots of answers like, oh, you must be tired, or you're crazy, or you fell. No, I didn't do any of that. Some of the kids got it right away. I was representing myself as the x-axis, okay? Me as an independent researcher. Also, I'm the only teacher in the room. That kind of makes me independent. So the independent variable gets plotted on the x-axis. Those are some short legs. Okay, and then what I did is I asked students, I said, you know what? I said, I'm an independent teacher in here, and you as my students depend on me. All right, so you're dependent on me. You're also dependent on your parents, so we could consider you dependents. So I asked them to stand up, and they did. Entire class of students standing up. And I asked them to try and figure out what they represented, and some more quickly than others realized that I was representing them as a y-axis, so they're standing vertical. These are the dependents. So this is the dependent variable getting plotted on the y-axis, and this is the independent getting plotted on the x-axis. So another thing, if you are graphing and we're using a spreadsheet to graph, the spreadsheet looks somewhat like this, and we often organize our data in columns. By nature, the right-handed, actually left, the left-handed column always represents an x-axis, and the right-handed column always represents the y-axis. So if we were going to make a chart in a spreadsheet program, we would highlight this data. Oh, that went south really fast. I'll see if I can erase it. Oh, Oh, I erased the whole thing. Here, let me do this again. So I'm just highlighting the numbers. Actually, you can see the boxes highlighted there. Let's see how good I can go up. Oh, that's a little bit better. I highlight this and then I can go to insert chart. And when the graph is made, temperature will indeed be on the x-axis and the time will be on the y-axis. So I'm clicking, but it's not going anywhere. What's happening? Oh, so here's a summary. The left column is the x-axis, also the independent variable. And the right column is the y-axis, and it's also the dependent variable. Okay, enough of that. So I'm going to give you a strategy now for how to identify the independent and the dependent variable. And we can look at information that's given to us. It doesn't matter what kind of information. It might be a research question, and we're going to investigate each of these today. It might be a hypothesis, a summary statement that talks about a brief summary of the research, or actual data and charts. And what we want to do is we want to complete this sentence. The blank causes the blank to change. If you were assigned the independent dependent variable worksheet, this was the sentence that was repeated again and again and again for you to be able to identify what an independent variable and a dependent variable is. So the independent variable is always the thing that's causing, it's the cause, and the dependent variable is the effect. So if you can remember to refer to this, if I ask you what is the independent variable, what is the dependent variable, if you can create this sentence, it will help you determine that each and every time. Okay, so we're going to talk about a research question. So this is just a question that includes an independent and dependent variable, and it always it's easy to recognize because it's the only thing that we have that ends in a question mark. So what students were asked to do in class is look at this question. Here's an example. How will changing the amount of dissolved salt in water affect the boiling temperature of the water? Well, lots of students wanted to answer it right away because of some sort of previous experience, but they were asked what the independent variable is, and they discussed among themselves, and they decided that it was the amount of salt. Remember, that's what we're changing. That's what we're trying to see if it will cause anything to happen. So the amount of salt was the independent variable. And what is it going to be? What is it going to affect? The effect is going to be a change in the boiling temperature. So that is the dependent variable. Again, if you have to identify this, you can finish the sentence. The blank causes the blank to change. Now these blanks are really small, just like they were on the worksheet, if you remember, if you were assigned it. So I'll just write down here, the amount of salt causes the boiling temperature. And this is, again, how we remember this is always our independent variable, and this is always our dependent variable. So if I ask you to create a research question, this can be a starter sentence that we could use. And we could just have the starter sentence with the blanks. Will changing blank cause blank to change? Or how will changing blank affect blank? So I will remind of this technique when we are asked during practice to create a research question. A hypothesis is a testable statement, and it's also an educated guess. It's based on observations and research that you may have done, and it is best framed as an if-then statement. So it's important if you see a statement and there's an if and a then, it's likely a hypothesis. All right, so here's an example. This is a hypothesis for the research question that was originally asked. How will the amount of salt dissolved in water affect its boiling temperature? If the amount of salt dissolved in water is increased, then the boiling temperature will be higher. So this is the hypothesis. I'm clicking. So if we have to write a hypothesis, this is a strategy that I will remind of again when we do some practice on writing hypotheses. So if blank changes, then blank will. So this is just a starter sentence that we can use to create a hypothesis. A summary statement is just a brief statement that summarizes experimental results. Here's an example. In an experiment to determine the changing amount of salt dissolved in water, I think I might have a typo there, to determine if changing the amount of salt dissolved in water affects the boiling temperature, it was discovered that higher amounts of dissolved salt resulted in higher boiling temperatures. This is an example of an experimental summary. And another example is data and charts and graphs. With any of these, you should be able to determine what the X or what the independent variables are and what the dependent variables are just by looking at it. And also remembering that you can complete the sentence, the blank causes the blank to change. Here, if I ask you what the independent variable is, you can immediately look to the x-axis and say it's the salt concentration, because on a graph, that's where the independent variable lies. The boiling point is the dependent variable. Here, you can see that what's repeatedly being measured here is what we're looking for, the results. So boiling temperature is the dependent variable, and what we're controlling is the amount of salt, which is the independent variable. So here is, we have to categorize. Is it a research question, a hypothesis, an experimental summary, or data results? There. Oh, you can see the word experimental now, but I'm putting myself back up there. Nobody puts baby in a corner. That's a Dirty Dancing reference if you're not sure. I'm putting myself down here. I'm not in the corner. I'll probably have to move myself shortly. So I lost it. Here it is. Will the starting temperature of a sodium acetate solution affect the rate of crystallization in a reusable hand warmer? Well, this might seem really, really complex. Sodium acetate solution, crystallization. Let's dissect it. Will the starting temperature of a blah, 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 blah affect the rate? So the starting temperature causes the rate to change. This is a question mark, so you can see that it's a research question. So the starting temperature causes the crystallization rate. I wonder if you can hear that little clickety click, 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 click. To change. All right, so the starting temperature is going to be our independent variable, and the crystallization rate will be our dependent variable. So what students did in class, since you missed it, was that they had to create this question or this statement on a whiteboard and then identify the independent and dependent variables using this method. So the independent is the starting temperature and the dependent is the rate of crystallization. All right, and here's the practice. Oh, no, it's not practice. It's more practice using the same thing. Will the starting temperature of a sodium acetate solution affect the rate of crystallization in a reusable hand warmer? If you want to pause this right now and try writing your own hypothesis to see how well you do, remember that a hypothesis is an if-then statement, and you might not have any idea how to predict this if you don't have any experience with it. But students were able to come up with it. And basically what I was looking for is that there was an if-then statement. So if the starting temperature of a sodium acetate solution is warmer, then the rate of crystallization will be slower. Okay, this was a picture, and we had to categorize as a research question, a hypothesis, an experimental summary, or data results. And you can see I have the answer bolded here. These are data results. Uh-oh, I'm just moving all over the place. Back in the corner I go. What is the independent variable? So here we have a chart here, and in class I mentioned that these are methanol, ethanol, and propanol are types of fuel. And methanol is used in racing fuel. So these are different types of fuel. So what is the independent variable? We can very quickly figure that out by remembering that me as an independent researcher lays on the floor in this horizontal way. So the types of fuel is going to be our independent variable. So I just had this as a slide show that I made available to somebody offline. So I put in parentheses here that I explained that these are types of fuel, which I just explained to you too. What is the dependent variable? The dependent variable is going to be the heat output. And some students put average heat output, and that's okay. They're both acceptable. All right, so students then were asked to write the original research question, and remembering to use this fill-in sentences as a guide. Either how does blank affect blank, or how will changing blank affect blank. So if you want to pause it right now and try your hand at writing a research question to see how well you do, I encourage you to do that. Okay, if you paused it and you tried it, obviously you're back, or you may just have kept listening. Here is an example. Will changing the fuel type affect the heat output? All right, here is a statement. It says, if the RPMs, or revolutions per minute, of a milling machine are increased, then the hardness of the metal will get softer. All of the examples I'm giving you here are actually experiments that were done by Oconto Falls High School students in previous years. So this was one. This was another one, a student whose dad owned a fabrication shop. So it is a hypothesis, and you can recognize that by the if and the then. So practice what might have been the original research question. So to get to that original research question, I remind you that you want to say, how will changing blank affect blank? And here is an example. How will changing the RPMs, or will changing the RPMs of a milling machine affect the hardness of a metal? This student's hypothesis was wrong, actually. After the experiment done, it was discovered that the metal got harder when the RPMs were increased. All right. So it has been shown that higher milk fat content of homemade ice cream causes the freeze time to become longer. And we have to categorize this. Is it a research question, a hypothesis, an experimental summary, or data results? This is just an experimental summary. And the question posed in class is, what might the graph look like of this experiment? So students had to figure out what the independent variable was, what the dependent variable was, and then come up with a possible graph. And this is one that students came up with in class. I actually took a picture of it. So let's figure out how this was done. So the blank causes the blank to change. So it's been shown that higher milk fat content of homemade ice cream causes the freeze time to change. So this is the percent fat, and it causes the freeze time to change. And here it says specifically that if we have higher amounts of milk fat, that the time becomes longer, it takes longer. So on the axis, the students put milk fat here on the axis. Oh, they did it wrong. They actually did it wrong. I'm embarrassed. I should erase this. Let me give you an example of what it should be. Whoops-a-daisy. I made a mistake. I am so sorry, and I'm not going to have time to fix it either. But we should have had percent milk fat here. And we should have had time here in seconds or minutes or however it is. And that as milk fat increases, the time increases. So I apologize for any confusion, and I'm really glad that I decided to go through how to get the information that we're looking for. Otherwise, I wouldn't have spotted this error probably, and it probably would have caused some confusion. So the next slide actually shows the students' results of this experiment. And, oops, I don't know what's happening. I think the world just wants to remind me of all of my mistakes. This is the actual student results of the experiment, and here you're seeing that the independent variable, the amount of milk fat on the bottom, they didn't use percent here. Was it a percent here? No, it wasn't even a percent. It was just higher milk fat content. So look at that, I'm causing confusion again. But we see the amount of milk fat, independent variable on the x-axis, and the time it took in seconds. Now it seems like weird that ice cream would only take up to 220 seconds to freeze, but they had the ice cream in little tiny test tubes with a thermometer in there, and they had some ice swirling around it with some salt, and the salt with that little tiny ice cream sample caused it to freeze really, really quickly. So they were able to repeat several experiments again and again and again. Okay, so this is the conclusion of this presentation, and I am sorry that you missed class, or if you didn't miss class and you're just watching this to reinforce some reinforce some concepts. Maybe you didn't do so well on the quiz that we took regarding these concepts, and you watch this video to help you prepare for a retake. I welcome you back. I hope that the examples that I gave were helpful in understanding independent variables, dependent variables, research questions, hypotheses, research summaries, data charts, and how we can be given information in a variety of ways and get back to those two very important variables in experimental design, which is the independent variable, which the researcher is controlling, and the dependent variable, which is what we're ultimately asking the question about. So thanks for watching.